So now we're going to be talking about lines and angles, and some of this might be review for some of you, and some of you it might be completely new, so please take notes accordingly. First of all, the word transversal. A transversal is simply a line that intersects two or more coplanar lines at different points. All of these lines in this diagram can be considered transversals. So for example, let me highlight some. If I were to pick line A, you can see that line A intersects this line, E, it intersects line C, and it intersects line D. Right, so A intersects all three of those lines. All right, so I could also talk about line E. So if I do line E, that is considered a transversal because it intersects D, it intersects B, it intersects A, and it also intersects C. So it intersects all of the other ones, doesn't it? So all of these could be considered transversals. We could do the same thing for the other ones as well. But transversal just means it intersects two or more different lines. So now why do we care about transversals? Well, when we have transversals, then we have some angles that start to become interesting. So these names, I hope you've seen them before, but if not, take some really good notes. Alternate interior angles. So two angles are alternate interior angles if they lie between two lines on opposite sides of the transversal. So we're specifically talking about a transversal crossing two lines, and then we're talking about opposite sides of the transversal and in between the two lines. So if I look at N and Q, all of these, let me highlight again, all of these angles in here are in between those two lines. But when I'm talking about alternate interior angles, I'm talking about angles that are on opposite sides. So for example, angles 5 and angle 4, and then also like angle 6 and angle 3. Now I am using arcs only to indicate where those are. I'm not necessarily saying they're congruent yet. All right, notice that these lines are crooked, so these angles do not have any meaning as of yet. Right now we're just looking at location of those angles. The next type we see is alternate exterior angles. So again, if we're talking about a transversal cutting two different lines, we want to look at the angles exterior of the line. So that's kind of the opposite of where the interior ones. So 7 and 8 would be on the exterior, 1 and 2 would be on the exterior. All right, but when we talk about alternate exterior lines, we want ones that are on opposite sides of the transversal. Here's our transversal. So they have to be on opposite sides and on opposite parallel line or opposite lines. So I can't say 7, 8. 7 and 8 are on opposite sides of the transversal, but they're on the same line Q. We want them on opposite lines as well. So we're talking about 7 and 2. And also 8 and 1. So those are what we consider alternate exterior angles. Another kind is called corresponding. So corresponding means that they're going to be on the same side of the transversal. One's going to be on the interior and one's going to be on the exterior. And they're not forming a linear pair. So I'm highlighting the interior ones with yellow, exterior ones are green. So I can't do 2 and 4. 2 and 4 would be a linear pair. But I can do like 2 and 6. Those would be corresponding angles. Or on that same side, I could do like 8 and 4. Those would be corresponding. So let's write, I said 2 and 6. And then 4 and 8. And then on the opposite side, we could have some more, 2 more pair. So angle 1 and angle 5. And then another pair would be angle 3 and angle 7. So those are all what we consider corresponding angles. Consecutive interior angles, a lot of times people call these, instead of consecutive interior, it's same side interior. Same side interior makes a little more sense because it describes the location a little bit better. But here again, we're going to be on the same side of the transversal, but on the interior only. So we're only doing the interior, but we have to do the same side. Okay, so we're talking about like 3 and 5, or 6 and 4. Okay, so angles 3 and 5 would be a set of same side interior angles, and then angles 4 and 6 would be same side interior. Okay. So this might be a good practice for you. Pause the video and see if you can name these sets of angles. So check your answers, see if they match mine. Hopefully you've been able to identify them. And if not, then that's something we should ask about and go over in class. All right, so notice in this diagram that the lines that the transversal cross, so these two lines, they look like they're parallel, right? So that's what we're going to talk about next. That's really why we care about these, is when we have parallel lines and a transversal cutting them. So these next postulates and theorems will be on your proof cards because we will be using them in proofs. Okay, so the first one, corresponding angles postulates. If two lines are cut by a transversal, and I don't know if you've seen this before or not, but all of these start with the same if. If two parallel lines are cut by a transversal. So you have to have the situation in order for this to be true. When we were going through the examples of these types of angles, our lines were not marked parallel. So we wouldn't know this relationship about any of the angles in those previous diagrams. So now we are saying we have to know that they are parallel. And remember I said these solid arrows mean that they're parallel. So I have two parallel lines and they are being cut by a transversal. So if that happens, then the pairs of corresponding angles are congruent. So for example, angle 1 and angle 2, we can mark those congruent. Alternate interior angles, again, if we have that same setup, two parallel lines, and they are cut by a transversal, then all of the alternate interior angles, like for example 3 and 4, those are also going to be congruent. Okay, and then the next one, consecutive interior angles. Remember, another way of saying that is same side interior. Okay, so if we have two parallel lines cut by a transversal, and I see that I have same side interior angles, these are not congruent. These actually will add up to be 180. So the word for that, remember, is supplementary. That's another reason maybe to use the term same side interior, because same side interior starts with S and supplementary starts with S. It's the only pair that's supplementary with these types of angles. And then don't forget, we also had alternate exterior angles. So again, parallel lines cut by a transversal, alternate exterior angles will be congruent. So all of those should be put on your proof cards. You should also have this perpendicular transversal theorem. So this one is saying if a transversal is perpendicular to one of the two parallel lines. So here's your if. You have to have this in your diagram. So I have two parallel lines, it says that, and I have a transversal, but I have to know that that transversal is perpendicular to at least one of them. If we know that, then it is perpendicular to the other one as well. So I would know that it's perpendicular to that other line. Okay, and we can go through a proof later, but you can see that those are corresponding angles, so that should make sense. So make sure you have those down. Let's look at this kind of problem. So we're trying to figure out, this is kind of like the old SAT problems, which value is greater? Is column A greater? Is column B greater? Are they equal? Or do we not have enough information? So let's look at these diagrams. Oh, they didn't mark anything parallel. Well, I'm going to mark these parallel, otherwise there's no point in looking at this. So we're going to say that angle A, or line A and line B are parallel. And then we're also going to say X and Y are parallel. So when I have a different set of parallel lines, I use double arrows, just like we would use double arcs or double tick marks. Okay, so if I look at 2 and 8, what is the relationship between 2 and 8? Well, 2, if you look at 2, I'm either using, this is my transversal, and then these would be my parallel lines. Do you see how 8 does not touch that same transversal that angle 2 does? So that way would not work. So let's back up. Let's try another way of looking at this problem. Maybe line A is our transversal. So that would mean X and Y are the two parallel lines. But again, angle 8 is not on that same transversal at all. So I can't say anything about 2 and 8. So this would be, since I don't have enough information, I would say D. They didn't give me enough information, did they? Whoa, back up for a minute. I totally overlooked one piece of information. They gave us that this is 120. So now having seen that, now I have different information, don't I? This is the key to helping me solve this. So this means that 2 and 120 are corresponding angles. So that would mean angle 2 is 120. Now 120 is on the same transversal with 8. So let me trace out that transversal. So 8 and 120 are on this transversal. And that would mean these are their parallel lines. So 8 and 120 are corresponding. So then that means that 8 is also 120. So now I can go back and change. That totally changes my answer, doesn't it? So now I can say those two values are equal because now I have that 120 to help bridge the gap there. So we're going to say C on that one. All right. Sorry for that, me overlooking that. All right, number 7, angle 10 and angle 6. So I'm going to get rid of my old marks here. So 10 and 6. So here's 10, here's 6. I'm going to be adding those up. So those are on the same transversal right here, which means these are their parallel lines. And those are same side interior. So we know that when we add those together, these would be 180. So now let's look at angle 3 and angle 12. Angle 3 and angle 12 are right here. Now these are not part of a transversal and parallel line set, but they are a linear pair. So we know that those would add up to be 180 as well. So here's another example where the two values are equal. And then angle 4 and angle 14, we're moving on. 4 and 14. So here's angle 4, and here, 4 and 14. So again, I'm kind of at a loss. I don't have this. Well, we knew this was 120, right? Okay, so that would make angle 12, we would know that is 60 degrees. So that means that if we look at this is our transversal, and these are our two parallel lines, you see 14 and 12 are corresponding again. So that means this is 60 degrees. And then if I look at a different set, so now I'm going to go to treating this as my transversal. So these would be my two parallel lines. So 4 and 12 would be also corresponding. So I could say that's 60. Another way you could have looked at that is 4 and 8 are same side interior, so those would add up to be 180. All right, so these are both going to be 60 degrees. So again, we have that those are equivalent.